My name is Lauren Kelleher from Cornwall University, and I will be presenting on the topic of Reuleaux's 6 mechanical elements. Now, before I begin, a basic understanding of who Reuleaux was is required. Franz Reuleaux was a German mechanical engineer from the late 19th century. Franz designed over 800 models of mechanisms. He was responsible for developing the fundamental concepts of modern mechanisms used in today's engineered products. Reuleaux's 6 mechanical elements are used in today's engineered products. These elements include levers and cranks, wheels and gears, cams, screws, things to transmit tension or compression, and things that transmit intermittent motion. Now, the lever is one of the basic machines of science. The lever, or the type of lever, depends on the placement of the fulcrum and pivot point relevant to the effort and the load. For example, a Class 1 lever has the fulcrum between the effort and the load, a Class 2 lever has the load placed between the fulcrum and the effort, and a Class 3 lever has the effort between the fulcrum and the load, as you can see in the diagram. The closer a load is to the fulcrum, the less effort is needed. Cranks are very important mechanisms. They are used to transmit the input motion or force to the desired location. Cranks have the ability to change the direction of force, change the length of motion of the force, or split the motion and force over multiple paths. Gears, cams, and other related mechanisms are considered as kinetic pairs. These machines transfer or change an input rotational motion and force to an output motion and force. The output may be either rotary or reciprocating motion. Wheels and axles act like a rolling inclined plane. They make things move by removing the friction. When teeth are cut into the wheel, gears are made. So gears are basically toothed wheels fixed to an axle. Gears and axles are a basic mechanical machine. The gear attached to an axle, i.e. where the input force is being applied, is known as the driver, whereas the gear fixed to an output axle is known as the driven gear. When more than 2 gears are connected, the machine is known as a gear train. The motion of the driver gear turns the driven gear. However, the gears travel in opposite directions. So incorporating an idler gear, as you can see in the figure, between the two will ensure both gears travel the same direction. And cams are similar to gears, although they don't have teeth and they are not consistently round in shape. Screws are mechanisms that convert rotational motion and force to a linear motion and force. A screw may be seen as an inclined plane in the round with a wedge at the tip. So as an example given, screws may act as a worm gear. A worm gear is cylindrical and bored or hollow for mounting on a shaft. The teeth are always formed on an angle to the axis, like a screw. Now, another one of Reuleaux's mechanical elements is things that transmit tension or compression, such as belts or chains used to drive the wheel of a motorcycle. Tension and compression are terms used to describe how forces are acting. For example, if an object is subject to tension, it is likely to be pulled or stretched, whereas if the object is subject to compression, it is being pushed or squished. Belts and chains are examples of mechanical power transmission. Belts operate on pulleys or sheaves, whereas chains operate on toothed wheels called sprockets. The change in belt or chain tension or compression engages and disengages power flow. Now, the 6th mechanical element is things that transmit intermittent motion. So intermittent motion refers to motion that stops and starts at intervals, such as a ratchet used in a clock mechanism. A ratchet mechanism is based on a wheel that has teeth and a pawl that follows as the wheel turns in the one direction. As the ratchet wheel turns, the pawl falls into the dip between the teeth, which can also be seen from the diagram. So during this short presentation, I have described and given examples of Reuleaux's 6 mechanical elements. You should now have a basic understanding of the elements and their properties or use. Thank you for watching.